Hi students, let's look at this question here, which was taken from the year 2015, paper 1, question 9 of part A. This question is on complex number, taken from the H2 Math A-level paper. Alright, so in this question here, we are given that the complex numbers W is such that A plus BI, and A and B are non-parallel real, non-zero real numbers. The complex conjugate W is denoted by W star, and given that W squared over W star is purely imaginary, find the possible values of W in terms of A. Okay, offhand I could think of two methods of solving this. One is using the argument of the complex number to try and solve this, and the other is using algebra. I prefer the argument method, but the argument method will require you to use some trigo, trigo knowledge. Okay, so let's look at the first part. So if you want the W square over W conjugate to be purely imaginary, what we know is that we want this to the argument of this would have to always hit the imaginary axis, right? So in other words, if you look at this, you just want it to keep hitting this imaginary axis as purely imaginary. So you start off with pi over 2, then you keep adding k pi to it. Right? So this will be pi over 2, just eat k pi, and where k will just be integer value. So in other words, you start with pi over 2, then you just keep adding 180 minus of 180. You just keep adding it, then it will just give you the argument which will always make this purely imaginary. So then what we need to understand is this argument here. Argument behind a logarithm, just take note. So what we do is we get this guy here. Then we take the pi out. I'm going to take the pi out here. Half plus k. Then this will be 2 argument w. W conjugate is negative argument w, okay? Then this guy will be 2k plus 1 over 2 pi. Then from here, what we can get is 3 argument w is equals to 2k plus 1 over 2 pi. And argument w would just be 2k plus 1 over 6 pi. Now take note, so this argument w here would be the entire possible arguments which will give w squared over w conjugate to be purely imaginary, but it doesn't mean that we need to accept everything. We probably need to reject some. Okay, so what I can do is I'm just gonna put into my calculator and see. Here, what I'm gonna key in is 2k plus 1 over 6, right? Don't put in the pi, it's fine. So this case here, what we get is 2x plus 1. Then this guy will be 6. Okay, so second table, this will be all the possible arguments I can have. Just add a pi to it. So 1 6 pi, half pi. Then after which we have all these 5 over 6 pi, 7 over 6 pi, 3 over 2 pi. Okay, all these are the possible values. So what you make sure is to understand that this is the argument. Then if you think about it, for a plus bi, right? So this is a plus bi. A positive value, b, it could be negative as well. So this will be argument of w. Okay, here. So we know that this guy will be b. If this is w, right? W is a plus bi. This is my a. So tangent argument w will just give us b over a. But the thing here is take note, you need to reject 90 degrees. Okay, this is 90 degrees because a is not 0. In order for argument w to be 90 degrees, a will be 0. So you have to reject this, okay, as a is not 0. Similar with this guy. So this whole entity need to reject because 3 over 2 pi is actually 270 degrees, okay, which is also only when a is 0, then you get the argument there. So essentially what we only need is these guys here, all these guys here. Okay, so you don't want anything to be like so essentially think about it. Tangent argument w will be b over a. So if you tangent argument w, okay, the entire thing here, you realize that negative pi over 6, that will be 1 over root 3, 1 over root 3, negative 1 over root 3. Okay, this will be negative 1 over root 3. This is be positive 1 over root 3. This will be rejected. Then 5 over 6 pi would be negative 1 over root 3 because this is this second quadrant here. then 7 over 6 pi will be 1 over root 3, and so on. Okay, so but if not, you could just use calculator, you could check. Same thing. Now what you do is in calculator, if you're not sure, you put a tangent, then you put in the value of 2x plus 1. Okay, then you put over 6 here, then you put a pi. Okay, then you realize that the value here will give you negative 1 over root 3. 1 over root 3. Arrow just means infinity because tangent 90 is infinity, but this all just is, it just be 1 over root 3, negative 1 root 3. Okay, so of course this one you can just ignore because it's infinity. Don't care, that is just error as well. So there you go. So essentially b over a could be written as plus minus 1 over root 3. These are the possible values here. Okay, so hence b would just be plus minus 1 over root 3a. So w equals to a plus bi, right? That will give us w equals to a plus minus 1 over root 3a I. So a over root 3i. Okay, so this is how you use the argument method. You will require a bit of trigo, but it's good to just practice using a trigo for method 1. But of course, method 2 is a more straightforward method. We will look at that. So method 2, what we're going to do is just use algebra. Shouldn't be an issue. You just w square over w conjugate. Then that will be a plus bi square over a minus bi. Right? You want it to be purely imaginary. It means the real part has to be 0. So you just equate it to 0. So I'm just going to expand this a square plus 2ab I plus b square. I square, which is negative 1. A minus bi. Then from here, what we get is group the real and the imaginary here. Okay, I think most students would like method 2, but I'll encourage you to just understand method 1. Okay, because harder questions you require you to do that. So then this will just multiply the conjugate of the denominator. So this will be a plus bi, and this is a plus bi. Then you just expand this, right? So this will give us bottom, when you multiply, will be a square plus b square. The top will just be a square minus b squared multiplied by a, right? So what you want is actually, okay, you don't really need to care about the imaginary part. You just need the, what do you call it, the real part. So the real part will be this guy and this guy here, right? So the imaginary part, you could group them one side, not an issue. From here, got this real part. So you know that the purely imaginary just means that the real part of this guy will just be 0. So a cubed minus b squared. The denominator you don't really care because, okay, even if you put it in, it will just be 0, right? I mean, the top will just be, numerator will just be 0. The denominator we don't really care. So b squared, a equals 0. A squared minus 3b squared. Okay, so a equals 0, reject as a is not 0. Then a squared equals to 3b squared. So we know that b squared is just a squared over 3. B will just plus minus a over root 3. So hence, w will just be a plus minus a over root 3 I. Okay. There you go. Okay. So that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.